Hi everyone, my name is Matthew Doyle. I am a former game developer and currently work for Autodesk in the Media and Entertainment Games division. Today I'm going to talk to you guys a little bit about Stingray in the 45 minutes that I have. I'm going to cover most of the basics of using Stingray, and we won't be able to go too deeply into each topic, so this will be more of an overview of some of the features that Stingray provides, and certainly not all of the features that Stingray provides. But I'm going to try to cover some of the more important stuff in the time that I have. Now, what you're looking at right now is the Autodesk Games Launcher, which will allow you to launch the Stingray editor among other tools such as Maya LT, Maya, 3ds Max, Mudbox, whatever else you may have installed. We also have the tabs here where you can see some of the content that is being put out for Stingray. We have including assets such as this low poly landscape that you can get, and well, we also have tutorials and new template files. We'll talk briefly about what templates are inside of Stingray here pretty soon. And we can sort this by learning and by assets. And so here we get a nice kind of a portfolio view, a tiled portfolio grid view of some of the assets that you can already get from the Stingray, from the Autodesk Game Store called Creative Market. And anyway, so this is the launcher. We're going to go ahead and just use this button here to launch the Stingray editor. Now, if you have other versions of Stingray, you'll be able to choose them from the drop down here. So we're going to go ahead and launch the 1031. That's the initial release of Stingray. Okay, so when you first bring up Stingray, you're going to see the Stingray projects window, and in here you'll be able to add new projects simply by clicking the button here and choosing the name, the directory, and a little description. You can also add an existing project, which allows you to add a project you may already have. Maybe you copied it from someone else on your team. And of course you can remove projects. Now the great thing is I have my projects here. I can either double click on these to just launch the project in general, or I can actually choose the level from that project that I'm interested in. So you notice as I click on the different projects, it shows me the different levels that are tied to those projects. So I can much more quickly get right into the level. Here is the templates tab, and on the templates tab it allows us to create new projects based off of these templates. So you have a basic template. It's a very simple template. If you look on the right here, it tells you everything you need to know about it. It has basic shading environment associated with it, and some scripting for allowing for a camera and a walk around camera. Then we have this character template. If you're doing anything with an animated 3D character, it's kind of got everything all set up for that. We have an empty template, self-explanatory. The vehicle template when it has for vehicle physics and so forth. And then we have a VR template. Stingray does support the Oculus Rift, and they will support other platforms, I'm sure, going forward. But for now, I think Oculus is the only one that it currently supports. But here we have the template that you can load that up and begin creating VR content that will run on the Oculus. Okay, so let's go ahead and jump right into Stingray Editor, and to do that, I'm going to load up this project here that I have called Subway, and we'll talk a little bit about the visual fidelity of Stingray in this project, and we'll talk a little bit about specifically shading environment as well as the screen space reflections and also cube map reflections, which are done with what are called probes, lighting probes. Alright, so here we have the Stingray editor, and it's pretty straightforward. It's pretty standard that you'll see in most game engines. You have your 3D viewport here, and the controls are pretty straightforward. It's hold down the Alt key, left mouse button to orbit, middle mouse to pan, and right mouse to zoom. And these mimic Maya's controls and Maya LT's viewport controls. You have some options here in your viewport that you can set. You can see here that we can adjust the field of view and the far and near ranges for fog, and we can change our viewport camera here. If we had multiple cameras, they would be listed here. We can change the types of rendering that we want to see, and we can also turn grid and gizmos on and off. We can also press G. So by pressing G, I turn the grid on and off. All right, and This is basically just an empty scene here. We have a light, and we're going to load a scene into this in a moment, but I can also make this 4-up view. So we have our usual cameras here, top down, top, left, and right. But in this case, they're all perspective. Okay, I'm going to go back to the single view. Now over here on the right, we have our Explorer, and the Explorer is basically just a hierarchical graph view of everything in the scene. Right now there's obviously not much. What we are interested in here is this shading environment, and we're going to talk more about that when I load an actual level. We also have our Create tab here, and this allows us to create objects. We have helper objects such as these for navigation, which we're going to talk about a little bit later. And then we have miscellaneous objects like triggers, audio, and so forth. If we go back up a little bit here, we can also add cameras, other objects such as planes, cones, cubes, spheres, and so forth, and some prototype objects. And then we have our navigation window here, which is not something you're normally going to see. I've added it, I've docked it myself. If you want to dock a window, you just pull it away like that, or you can pop it right back in. You can see I can dock it pretty much anywhere that I would like to do so, and I just like to keep this here. All right, now navigation, again, this is basically our AI pathfinding tool built into Stingray. We'll talk more about that in a little bit. All right, now if you ever want to see these tabs and they're not actually up, you can just go to the window menu here, and all of these tabs are going to be found on this menu, and then you can obviously open them, and then you can dock them from there. Now below that we have our property editor. This is when you have an object selected, such as in this case I have the shading environment selected. All of the properties for that object are going to be found down here. Alright, so let's just move around counterclockwise here. We've got over here, we have our asset preview window, and basically if I were to select an asset, so we'll go into content, models, and let's see, let's go to props, and then phone booth here. Let's just select it. You can see here's my asset preview. The viewport works just like the main viewport, uses the same controls, gives you a nice preview of that asset before you drop it in. Of course, dropping an asset into the level is simple, a matter of dragging and dropping, or you can simply use the place tool. So if we look over here on the left, we have our toolbar for the viewport. First up, we have our ability to test the level. So if I were to press this, it would actually launch the level. And then we have the ability to run the project, and we have our move tool, which we're already defaulted to. So if I click here, we have our usual gizmos for moving around, rotate and scale. And then here we have our place tool. So if I click the place tool and just select my asset, I can just start placing it multiple times in the level, just like that. Right click will exit that tool. Right? I'm going to turn the grid off here. And then below that we have grid step and angle snap, rotation snap, in case we want to rotate. So if I go to rotate, and by the way, your move, rotate, and scale tools are hotkeyed just like Maya. So you've got W, E, R, and so we'll go to rotate with E, and then let's say I turn on the snap, and if I hold it down I can change the snap value. So let's go with 10-degree increments here. So now as I rotate, it should be rotating in 10-degree increments, and if I go back to 45, we can see here we now rotate in 45-degree increments. And let's just go back to 1 degree, but you can also choose custom, obviously. All right, and then the same thing, we have our grid snap. We can change the size of our grid. We can turn on snap to grid, snap to point, snap to surface. We have all the snapping that we will probably ever need in this one tool here. All right, and so obviously you saw the asset browser when I added the phone booth, and the asset browser has the project folder here, and if you open each folder, that's where you're going to find all your assets. It's basically the folder structure of your project here on the left side, and then on the right side the contents of each folder. You can see here the breadcrumbs of that particular folder. You can do a search for an asset. So if I do a search for phone, that brings us up all the phone booth assets, and you can also import a new asset using this button here, and we can import FBX files and so forth. This panel here is the log console. It gives me errors and warning messages, and also good messages of anything that is going on in Stingray. If you ever have any issues with your content, it's a good idea to look in the log console. This window may not be open by default. If it isn't, you can go obviously to Window, Log Console, and then we'll just pop it right in here, dock it. That's where I like to keep it. All right. Below this, you're going to find the command panel as well as the I'm not really sure what this would be called, but basically this is kind of like the log console down here as well. So you're going to see basically your log down here. That same thing you're seeing here will be displayed down here, and you can basically get more or less info on that information there. And if I double click it, it brings up the log console. Okay. So the cool thing about the commands here is that I can run Lua. So I can type in Lua here. I can just type print hello world. Oops, misspelled that. Hello world, just like that. And inside the log console, we should see hello world. There we go, right there. All right, so let's go ahead and load a level, and let's talk a little bit about the visual fidelity of Stingray. All right, so once again, I can click on the levels here and see the asset preview. What I really want to see here is this train station. So let's go ahead and double click that to load it. Okay, so here we are. I'm going to turn the grid off and you can kind of get an idea of some of the quality that Stingray is able to output. Now, you'll notice there's a lot of distortion here, so these columns look really rounded, and that has to do with the shading environment. Shading environment also controls the visual, the reflections. So we can see the reflections everywhere here, as well as ambient occlusion and a host of other effects. So let's actually look at the shading environment and play with it here. So if we go under our Explorer and then click Entities, we can once again select our shading environment. I'm just going to bring this property editor up a little higher here. Now at the top of the property editor, we can see here all of the different aspects of our shading environment. So we have global lighting, cascade shadow maps, fog, exposure, screen space, ambient occlusion, screen space reflections, depth of field, motion blur, and so forth. All right, so this just kind of separates what we want to work on down here. It only shows what we've picked. However, if we just go back to the top level here, we can see everything at once, which can be kind of unwieldy. So that's why I like to just go with these and pick one at a time. So we have our global lighting here, and global lighting is basically like ambient light. And so we can see here we have baked diffuse tint here. That's set to 0.2. You can notice a very slight change when I change that value to the tunnel area. It gets a lot brighter. So we'll just drop that back down to 0.2. And of course you can change the color and so forth. You can also use a diffuse map, and in this case we're using an actual reflection probe for our cube map that is baked from these little probes here. All right, so there are two ways to do reflections in Stingray. Now you notice this level has a lot of reflections, and the two ways you can do them are using reflection probes to bake cube maps. So you've got a cube map based reflection, which is a texture that basically simulates the reflection from all different directions, and then that gets basically baked onto reflective surfaces. Or you can use what's called a screen space reflection. Now the difference between the two is pretty stark. The screen space reflection is real time. It runs on the GPU of the video card, and therefore it's more performance heavy, but on a good platform obviously it makes a huge difference because it's more realistic, it's more accurate, the reflections are more accurate, and the reflections do not require texture memory because it's all done at runtime on the GPU. Whereas a cube map obviously requires a texture, so it takes up VRAM on your video card, but it doesn't have as much of an impact on the GPU of the video card, so it's cheaper to run as far as performance goes. However, if you want something more realistic, you should go with screen space reflections because the cube map reflection is not as correct, it's not as accurate. All right, but if we were to take away these reflection probes here, you can see as I'm taking the reflection probes away, our reflections become less noticeable. Okay, now the thing about reflection probes that's kind of neat is you can place multiple reflection probes in the level, and those reflection probes will blend between them. So if you have a character walking here and you have a reflection probe there, and then you have the reflection probe here, as the character moves from, as the player moves from reflection probe to reflection probe, it updates what the player is seeing baked into the reflections, the reflective surfaces. Now you're noticing that there's still some reflection here, and that's because we are using not only reflection probes, but we're also using screen space reflections. So these screen space reflections are incredibly accurate. So you can see here, once again, this is on the GPU. The reflection is basically exactly what you would expect to see in this environment. All right, and so if we go to the shading environment and we go to the reflection probes, or excuse me, the screen space reflections, we'll click there. If I turn this off, there you go. So now we have no reflection on the ceiling whatsoever, no reflections in the environment at all actually, because we no longer have the cube map and we no longer have the screen space reflections. So we'll turn that back on, and here we go, we're operating on the GPU once again. Okay, you can see I can turn it on and off there. I can also adjust it, some of these values here. 0.2 is obviously the highest. Okay, and if I try some of these other values here, let's go min 1, let's go with min 0.1, and then we'll go with this threshold 0.01. So now we can see that we're seeing these reflections pretty much as we would expect to see them using screen space reflections. Alright, so we can just continue to play with these values some. See there what 0.01 brings us to, much more reflective. And see the screen edge threshold there, the highest is 0.2 again. You can type in 1 and it gives you 0.2. And that kind of blurs it out at the edge. Alright, now let's go ahead and turn that off and look at the cube map reflections. So to add a cube map reflection, we need to bake the cube map, and the way you do that is you go to your create windows here, or you go to your create tab, and then we'll go to our reflection probe, and we'll just drop that into the level. Okay. Now currently there is no reflection happening here, so we're just going to go ahead and bake that reflection probe. So we'll go under Window, Lighting, and then we'll bake reflection probes. There you go. So there, that reflection probe has been baked. You can see the environment on it now, and you can also see the new reflections, the cube map based reflections on the reflected surface here, the roof. And remember, again, it's not as accurate, so you can see here it's not really properly conveying what you should be seeing, but it's a good approximation, and most people won't notice it. It's not 100% accurate, but it is somewhat accurate. All right, so let's turn our screen space reflections back on. There we go, and it blends between the two. Now, let's talk about some of the other things here real quick, and then we're going to have to move on. But obviously, we already talked about global lighting. We can obviously control fog here. We can control the exposure. This is something that if you're a photographer, you'll be more familiar with exposure controls. We also have screen space ambient occlusion. If I turn that on and off, you can see the effect of screen space ambient occlusion. That is, again, running on the GPU in real time. It's not baked, and this is screen space again, just like the reflections, meaning that it's only what is on the screen that is being run and on the GPU. Nothing behind you or off the side, only what's in the viewport frustum. And of course I can adjust the quality. The highest quality here is 3. I can change the radius. So let's make it a bigger radius. I'm going to change the intensity. The intensity, the highest is 1, so we can go down to like 0.5, bring that down a little bit, back up to 1. Okay, and that basically gives it a nice look because it mimics what light does, how light kind of misses the corners, the way it bounces, so it gives it more of a darkened line at the corners. All right, also under your shading environment, you're going to find depth of field controls, and obviously depth of field has to do with, again, this is a camera terminology thing, but basically allows you to provide focus. And we have, all of these are basically camera, or if you're familiar with Maya or 3ds Max, you'll find the same basic controls. So you have your focal distance, focal region, region start, region end, near and far scale to control depth of field. We also have motion blur so that your cameras display blur on the screen if there's a lot of fast movement. You can adjust the lens quality. Now this is where I was talking about the distortion. Here we actually have a poor lens. That's why everything is so distorted. So we can adjust that distortion down a little bit or bring it back up a tad. We can also adjust the color of the fringes of our lens. So you can see here the highest value is 1. Bring that down to 0.5. So that gives you kind of a chromatic aberration from the lens. So you get that kind of a separation of colors, red and blue and green. And then of course we have our fringe intensity, which pumps that up really high. All right, let's bring that down some more. So it gives you an idea of what you can achieve with the shading environment here. We also have bloom. We can turn that on and off. You can see the lights have a bloom applied to them when it's on. And of course you can adjust all of the bloom stuff here. And we can even add a lens dirt map. And basically the lens dirt map comes into play when you see if we can get it on the screen here. You can see the little blue dots there. That comes into play when your eyes are basically being hit by bright lights. And you can see the lens, or I should say the lens is being hit by the bright lights, and you can see the dirt on the lens. And you can change what that lens dirt texture is. It's just a regular texture, any texture, PNG, whatever will work. And of course you can control the dirt amount, so we can really pump it up there, really give it kind of a nice look. And we can also tint the lens dirt, just like that. Also, we have a vignetting effect. So if you're going for that kind of older film look, you can do some vignetting and some color grading actually. And you can also use a color grade map for there. All right, so that covers the shading environment and some of the visual quality of Stingray using reflections with cube maps and the screen space reflections, ambient occlusion, bloom, and so forth. So let's continue talking about lighting a little bit more. We're going to load a different project here, and we're going to talk about the Beast integration inside of Stingray and how you use Beast to bake light maps. Now this isn't going to cover Beast in detail, but we will just show some of the basics here. And obviously I'm not going to bake the light map entirely in this presentation because it would take a little while longer than we actually have. So we'll go into our levels folder here, and we have our Beast example scene. Yep, that's the one I want, and we'll just go ahead and load that up. So Beast is basically the tool inside of Stingray that allows you to bake Lightmap. So here we have some Cornell boxes. The Cornell boxes are basically these boxes with green and white and red walls, and then some objects in the middle that allow you to see how light interacts with the world, how it bounces around, how colors can bleed from object to object. We can see a little bit of bleed on these objects and so forth. And what we're looking at are 4 different situations. So we have dynamic lighting with baked indirect lighting. So this light is actually dynamic. If I move it, you can see that it updates the lighting in the scene. We also have a scene here that has baked lighting with baked indirect lighting as well. So you can see if I move this, nothing changes. Here we have an example of emissive lighting. So all the lighting is coming from this sphere here, which has emissive. And here's an example of transparent materials and how lighting still works with the transparent materials. All right, so now we also have some reflective surfaces in here, so these spheres. Now, what I didn't talk about last time when I was talking about screen space reflections and so forth is not only do you have to have that set up with cube maps and your screen space reflection in the environment shader, but you do have to have a material that is reflective. So if I click on this surface here, and then we go to our property editor here, you can see the material for that object, and we'll go ahead and go to that material. And here's the actual material selected. And if we scroll down to the material here, this is using the shader, basic standard shader effects material inside of Stingray. And it has a metallic and roughness as well as emissive, ambient occlusion, color, and so forth, all of the inputs that you need for a material. And in particular, this material is what's called a PBS or PBR material. That's a physically based rendered or physically based shader material. And all that really tells you is just a fancy way of saying that it's a whole new way of creating materials that is supposed to be more artist friendly versus the old school way of creating spec maps and gloss maps and so forth and so on. But it still uses a lot of the same stuff. Your color map is basically your diffuse map. It still uses a normal map, but rather than specular and gloss and whatnot, instead we have metallic, roughness, and those two alone are enough to give you a wide range of surfaces that can be not metallic or completely metallic, very smooth or very rough. And the metallicness and the roughness control the reflectivity of a surface as well as the smoothness of that surface. So if I adjust the metallic slider here, you can see that it becomes very reflective or not reflective at all or anywhere in between. And then roughness here controls how glossy the surface is. So obviously here it's incredibly sharp, very shiny, but also very reflective. You can clearly see it's like a mirror. Whereas as I move the slider up, it becomes much more glossy, not quite so smooth, and that's because it's becoming a rougher surface, so the light is diffused as it bounces off of that surface. It doesn't all come straight back at you, so it goes in all different directions, creating a less reflective surface. So that's kind of a little 101 on PBR shaders. Mostly metallic and roughness are your new values versus specular, gloss, and a few other things. All right, so that's how you get the reflectivity on your surfaces for both screen space reflections, cube maps, and so forth. All right, so let's look at Beast and finish up our topic here on lighting. But before we do, also the emissive, I wanted to just say that the emissive works in the same way. It has an emissive quality to the material, so we'll just bring that material up. And once again, we have our shader effects PBR shader here, and this one has an emissive. You can use an emissive map, or you can just give it a color, and here's my intensity, and that creates the glow of that object. Simple as that. And because it's emissive, it emits light and therefore affects the light map. So let's look at how to actually bake with Beast, and we'll just bring up the Beast window. So we'll go under Window, Lighting and Shading, and then Bake Light Maps. All right, so this is the Beast window, and I'm just going to dock it over here. All right. And so here we can see a lot of the options for baking light maps. The type of light map, we want standard or directional. We can also choose direct and indirect for our illumination type. So we have direct and indirect lights. So we're going to go with both. We've got a custom preset here on quality, but we can go low, medium, or high. And of course, the number of samples. All these are basically options that allow you to control the quality of your light map and obviously the speed with which your light maps will be baked. Now, before you can bake light maps, all of your meshes, all of these objects have to have light mapping UVs. So on channel 2, in your 3D package of choice, Max or Maya or Maya LT, you need to, of course, create light map UVs on these objects. And as long as they have them, you'll be able to create light maps for them. All right, so we can do what's called a live bake, and I'm going to do that. I'm going to turn it on now, and all we got to do is hit bake. So you can see down at the bottom here, it's going to start baking. We're not going to have time to finish the bake, but as you can see, because it's a live bake, we can see the progress. And what's going to happen is Beast is going to continue to bake the light maps until they get absolutely perfect. And you can see here it's iterating on the light map bake, so they're slowly but surely getting better and better. until, of course, when they get finished, they'll be, they'll basically conform to whatever specs you put in here. And of course, if you don't want to put in the specs, you can just choose a quality preset and set it to the best or the lowest. All right. So again, we don't have time to show the Lightmaps baking, unfortunately, so we're just going to stop there. But that is how you bake Lightmaps inside of Stingray. It's very easy, very straightforward. There's really not that much to it. And of course, it takes into account reflective surfaces as well as emissive surfaces, and of course, the surfaces with transparent materials. All the shadows will look correct. All of the bounced light, all the color bleed will look fantastic. All right, so next up I want to talk to you a little bit about AI inside of Stingray. So we'll bring up a new project, and we're going to bring up this GameWare navigation sample. All right, so once again, we'll go to my levels folder here, and we're just going to bring up this navigation level. All right, so navigation is, in a nutshell, a multi-threaded A-star pathfinding tool. So that's just a fancy way, again, of saying that it's incredibly fast, and it allows your AI, the characters in your game that aren't player controlled, to figure out how to get from point A to point B. And it comes with a lot of tools that make it very easy to set that up. So first up, the very basic thing that navigation does is create what's called a nav mesh. And so here we have our nav mesh, and basically the nav mesh is what allows the AI to use the A-star algorithm, which is pretty much the standard algorithm in the games industry for pathing AI, if you're not familiar with it. It allows them to move from point A to point B using this navigation nav mesh. Now, to use navigation, we'll just go to our navigation tab here, and we can see, let's pull this down. There we go. We can see here I can delete this nav mesh, or I can simply generate it just like that, very quickly. So let's say I wanted to change something in my world. Maybe I want to move this object over here instead. And if I generate the nav mesh again, we can see that everything has changed to meet that new location. So very straightforward. All right. Now the cool thing about generating the nav mesh is not only is it fast, but it's also able to do dynamic nav mesh generation at runtime. That means if you have a level where maybe something blows up, a bridge falls apart, or a spaceship crashes into the ground and creates a crater, the nav mesh can be changed on the fly to change basically where the AI can go and where they can't go, so that maybe the crater would be blocked out because it's too deep or too steep or whatever, or the bridge gets blown up so there's no longer a path there, and then you can tell navmesh to generate the new navmesh on the fly, and it will get rid of that piece. Basically, navigation uses multi-threading and time slicing to make it incredibly fast. You can path hundreds and hundreds of bots at the same time. It's good for MMOs, shooters, whatever. And again, multi-threading and pathfinding or time slicing are just, basically programmer terms that mean it's incredibly fast. So rather than talk too much in depth on that, let's look at some of the tools that come with navigation. So obviously here on this navigation panel, we can do things like controlling the slope max, the step max, the entity radius and height, which will affect the way the nav mesh is generated. So if I change my slope from 45, the slope max from 45 to say 20, and we look at a slope here and then generate the nav mesh again, you can see that the nav mesh no longer allows for these slopes to be pathable. So we'll just change that back to 45. All right. We can also change the entity radius. Right now it's at 0.3. Let's make it 1. And you can see that the nav mesh now becomes much more narrow to accommodate for basically the larger radius of the characters. So we'll drop that back to 0.3. Regenerate. All right. So that is working with the nav mesh, but there are a few other things that you can do with navigation's nav mesh. You can basically add nav markers. So we can see here we've already got some markers in the scene. These are just navigation points that you can tell AI to move to specifically. If you want them to go somewhere that's not scripted, you just want them to go specifically to this point. Also, we have what are called grid graph connectors. So if you see here, we've got these steps here that are separated, and what we want is we want the AI to be able to know that they can go from here to here to here and so forth, even though these are separated. And that's how we do it. We do it with these. Basically, they're called graph connectors. All right. and you'll find that right there. So if I were to just click here and add one, you can see what it looks like to add them. Okay, and then you just move them and rotate them into place. All right. Now here in the world, we already have our our bot configuration. So if I were to select this guy here, that's our bot configuration. So if we go to the property panel, click on bot configuration, we get all of the information for our navbot, such as dynamic avoidance information, avoiding other bots, avoiding dynamic objects, and so forth and so on. A lot of details here that you can adjust for your bots, your AI. Then we also have our nav world, and this is the core which holds the data of the nav mesh and so forth. And you can also set some of the properties here. All right. Now, let's look at the tool. There's a debugging tool that comes with navigation, which is really, really useful for debugging your AI, figuring out if they're doing what you want them to, going to the right places, and what kind of performance hit you're taking with navigation as you run the game. So to do that, we're going to go ahead and launch from the window drop down here. We're going to launch Navigation Lab. Alright, so here's Navigation Lab. Again, this is an incredibly handy tool for debugging your AI, and we don't have time to go into this in detail. There's so much information here, but I just wanted to give you a quick peek at how you would use Navigation Lab to debug your AI live. And to do that, we're going to just move this over to the left, and we're going to move this over to the right, and we're going to go ahead and just play the level here. Now bear with me as I play this level. We have to basically fit this onto the screen properly. There we go. Alright, now we need to get back over to the Navigation Lab, and we're going to connect to the game window, and we can just close that window down, and now I'm going to change the camera to the game camera. Alright, so if I jump back over here and start controlling the character, you'll notice that the Navigation Lab viewport corresponds to the Stingray game viewport exactly. So we're seeing that yellow cylinder there is my character, the player, and these red cylinders are, or the yellow cylinder is the AI. Okay? Now the red cylinders are AI that are not currently pathing. The yellow cylinder is an AI that is pathing, and we can see that data there. We can also see the grid graph connectors here, so we can see the links for these objects. Okay. Now, if we jump back over to Navigation Lab, we can also get a lot more information here. So if we go over here to the Profiling tab, we can get a summary. So we can see here currently that navigation is running at about 0.1 milliseconds to path that bot. And we can get a lot more data here, the number of bots in the level, number of obstacles, nav data count, and much more detail here. You can go into a great amount of detail. So I don't really have time to cover all this in detail, but you can see here we can also pause and play, we can rewind and capture all of that data and get memory reports and quite a bit more here. We can look at smart objects, physics, all sorts of information here that you can look at, and a live connection to your game. Let's look at how you can move back and forth between Stingray and Maya or 3ds Max, and we're going to use this robot as an example here. And you already saw that I can right click on an asset and send it over to Stingray or to Maya. So if I right click on this robot and then find in the asset browser, here's our robot. Let's go ahead and right click and let's send him to Maya again. Alright, so here we have our asset, and we want to make some changes to that asset and see them reflected inside of Stingray. And to do that, it's quite simple. So for example, we might want to adjust the shape of the head here. So let's just go ahead and do that real quick. I'll turn on soft select, and we'll just make an adjustment here. Maybe we want it to look like that. And then maybe if I go ahead and grow the selection here, we'll just scale the entire head up. Just like that. Okay, so now we'll go ahead and send that change back over to Stingray using the update button. And Stingray is updating that. And there you go, just like that. You see the change live right there inside of your Stingray viewport, just like that. So that's not the only thing you can do. You can obviously do mesh changes, but you can do texture changes. You can also do things like adding lights or cameras or LODs. So let's just really quick add a light. So let's do this by creating a light here that we can actually add to our character. So let's create a spotlight, and we'll just move it up to the top. I'm going to turn on X-ray joints. Okay, and let's rotate it around about 180 degrees there, roughly. Yep, exactly. There we go. And just kind of tie it to that. And what we're going to do is we're going to parent it to this joint. There we go. So our light is parented to that joint. So now, if we update inside of Stingray, all right, now let's go ahead and add a surface that light can shine on. So we'll go over to Objects, and we'll just create a prototype surface here. And there's our light, just like that. Pretty neat. So now I could maybe change the color of that light inside of Maya. Let's make it red. Change the intensity. Update. And there you have it. The light is now red. Alright, so that gives you kind of a basic idea of how quickly you can send your data back and forth between Maya and Stingray, as well as 3ds Max or Maya LT. Once again, you can send a lot of information in the FBX file. That includes human IK rig information, lights, cameras. You can do mesh changes, texture and shader changes, and so forth, as well as LODs and a few other things. Now, talking about textures and shaders brings us to the topic of shader effects, and I don't have a lot of time to go into detail on shader effects, but I do want to show you the shader system in Stingray is exactly the same as the shader system inside of Maya, Maya LT, and 3ds Max. And so let's have a quick look at that. So if we actually select our robot, I'm going to turn off my X-ray joints, have a look at the robot here, find this character robot blue material, look at these nodes here on the property panel or the attribute editor inside of Maya. And then if we go over to our robot character here and we select that same material, it has the exact same nodes. They're identical to what you're seeing here inside of Maya. And that's because you have a one-to-one correspondence with shaders in Maya, 3ds Max, and Stingray. So you don't have to recreate your shaders. They're all transferred in the FBX file. So let's have a look at the actual shader graph here. So we'll go ahead and open Shader Effects. And once again, this is a physically based shader. This is called the Stingray physically based shader. So we have our color map, as well as our normal map. Then we have metallic and roughness, and emissive, ambient occlusion, and all that's put into our actual standard material for Stingray. So if I open that same shader, if I right click here and just choose open, inside of Stingray we have our shader graph editor. And this shader graph editor, of course you can dock it anywhere you like, but I'm just going to leave it as a window. You can see here that's exactly the same as the shader graph inside of Maya in Shader Effects. That's a one-to-one correspondence. You don't have to make any kinds of changes. The data will come over back and forth with the FBX file between the applications. So we can see here we have our color map, our normal map, metallic, roughness, emissive, ambient occlusion, just like we saw over here. So very powerful feature inside of Stingray, the ability to use the same shader effects graphs as you do inside of Maya and 3ds Max. So in closing, I thought I'd show you guys a quick little game here that was created very quickly. I think it was in less than 24 hours. And if we play it real quick, not very good at it. Haven't quite figured it out yet. But you can see we've got sound, music, nice kind of 8-bit feel to the game. Nice camera angle. You can see here the kind of stuff you can create. Very indie friendly looking. Now this game was created entirely without code. This was done using the visual scripting tool Flow inside of Stingray. So we can see everything here for the level. We've got the audio as well as the spawning system, the camera system, the scoring system, all of the information, all of the basically the code that you need to run this game, all done visually with Flow. Now a lot of these nodes in Flow are actually C++ in the back end. But the great thing about Flow, and I'll leave you with this, is that Flow allows you to create custom Flow nodes using Lua. And when you create those custom Flow nodes, if you go under Project inside of Flow, you'll find the nodes that you created for that project. So for example, here's an example print node that was created custom inside of Lua. Now, the way you do that is if we go to our script folder here and into Lua, you can see we have this flow callbacks. Let's go ahead and open that up in our script editor. And we can see our callbacks here. So we have example and level event. So once again, if we right click and go to project, we have our example print and our level event. All right. And we just have the actual Lua code here as to what those functions do. Now Lua is a very fast language, very lightweight, and considered to be one of the faster scripting languages out there for game development. And I believe that's why the Stingray team chose Lua, because of its lightweightness and performance. So you can see here the kind of game you can create using just Flow alone and Stingray's visual acuity here and all the cool effects that you can use with the shading environment, what kind of looks that you can achieve. Okay, so that's about all the time I have for today for this overview. I hope I've covered enough to get you started with Stingray, and we will be doing some webinars in the future that are much more detailed, that go in depth on some of the topics that we covered today. Again, this was mostly an overview of using some of the features. And we will be doing a Flow webinar that actually goes into considerable detail on how to actually use Flow to set up gameplay and character animation and whatnot. All right, so I hope you enjoyed this webinar, and we look forward to seeing you again next time.